Hello, this is disting mode 4B, which is the clockable LFO. Like the previous LFO, it generates two different LFO waveforms, a siny, triangly, rampy waveform on A and a square or pulse wave on B. The difference with this is that the frequency of the LFO is not set from a CV or from a knob, it's set from a clock pulse which is received on the X input. So if I just slow that down a little bit so you can maybe see it flashing a bit more clearly. So that's the clock pulse that we're putting in, and these are the LFO waveforms that we're getting on the output, which as you can see are in time. You can see that again also on these oscilloscopes. The top one here is the input clock pulse, and this is the waveform that the disting is generating on its output. So if I change the speed of the clock, you can see it tracks the output. It tracks the frequency with the LFO waveform. The waveforms are wave shapeable, exactly the same as the other LFO mode. If I plug in a CV into the Y input for the wave shape, for the triangle wave, it's for sine wave, it's sine in the middle. If I go negative, it's a ramp. If I go positive, it's a triangle. And for the square output, it's a square in the middle, and a narrow pulse that way, and a broad pulse that way. But we'll go back to the sine wave. Now, the other interesting thing about this mode is the Z control or knob is a multiplier divider on the frequency. So looking at our LFOs, at the moment they're nicely in sync at the same frequency. That's with Z on 1 times mode. If I change Z up to 2 times, 1, 2, you can see the frequency has doubled. There's one waveform there, and there's 1, 2 there. And if I keep turning Z, it goes all the way up to 16 times. And that's working perfectly well on the sine. If I use the square output, you can see how you might use that as a clock pulse multiplier maybe. And again, if we go so back to 1 times, if we go down the way, that's divide by 2. So now the top waveform, which is the input, has 1, 2, and the output has 1, and that goes all the way to divide by 16 as well, which we're not going to see on the oscilloscope there, but you get the idea. And again, that's not just the, let's go back to divide by 2. That works for the sine wave too, just to make the point there. So there you go, clockable LFO with multiply divide.